a quarterly merge was blocked for 4 hours because a cherry-pick security fix conflicted with itself. The root cause, cherry-pick creates a new SHA, and Git sees it as a completely different change. Let's break down Git Stash and cherry-pick, how it works, and the exact mistake behind that failure. Git Stash temporarily shelves uncommitted changes so you can switch branches cleanly. Git cherry-pick applies a specific commit from one branch to another, creating a new commit with a new SHA. Both are essential for managing context switches. When you run Git Stash, Git takes your modified tracked files and staged changes, bundles them into a stash entry, and restores your working directory to head. The stash lives on a stack and persists across branch switches. Here's a basic stash workflow. Use U to include untracked files and M to label your stash. Git Stash Pop restores changes and removes the stash entry. Cherry-pick takes a commit from one branch and applies its changes to your current branch. It creates a new commit with a different SHA because the parent commit is different. This is key to understanding the duplicate conflict problem. Switch to the release branch and cherry-pick the commit by its SHA. The new commit will have a different SHA, as shown in the log. A stash commit has no parent, so cherry-pick cannot compute a three-way merge. It always uses the stash tree as the base, leading to spurious conflicts. The rule is, never cherry-pick a stash commit directly. Attempting to cherry-pick a stash entry results in conflicts on every line, even if the changes are identical. This is because Git cannot determine a common ancestor. This is the same issue we highlighted at the start. Here's exactly why that happened. A developer cherry-picked a fix from main to release 3.1 without annotating the source SHA. 3 weeks later, merging main into release 3.1 caused a conflict because Git saw two different commits touching the same lines. The release was blocked for 4 hours. Cherry-picking a commit creates a new SHA, so Git treats it as an unrelated change during a future merge, causing duplicate conflicts. The fix is to annotate the commit with the original source SHA using the edit flag and a cherry-picked from footer. The fix is to always use Git cherry-pick edit and append the source SHA to the commit message. This provides traceability and helps Git recognize the change during future merges. For the immediate conflict, resolve by keeping the existing fix. When you cherry-pick without edit, the new commit has no reference to the source SHA. During a future merge, Git sees two different commits touching the same lines and raises a conflict. Always use Git cherry-pick edit to annotate the source SHA. Merge commits have two parents. Cherry-picking them requires the M flag to specify which parent to use as the base. Without it, Git refuses to apply the commit. Git Stash Pop deletes the stash entry even if the apply hits a merge conflict. If the conflict is unresolved, your changes are gone from the stash but not applied. Use Git Stash Apply when conflicts are possible, then drop manually. Instead of cherry-picking a stash directly, which fails due to missing parent, convert the stash to a branch first with Git Stash branch name, stash aten, then cherry-pick from that branch. This gives the commit a proper parent and avoids spurious conflicts. A stash commit is actually a merge commit with two parents, the head commit and the index commit. When you cherry-pick a stash, Git sees a merge commit and requires the M flag to specify which parent to use as the base. Without M, cherry-pick fails with is a merge but no M option was given. Always annotate cherry-picked commits with the source SHA to prevent untraceable duplicate conflicts during future merges. Use edit to append the source commit reference in the commit message. If you lose a stash due to a conflict, check the reflog or use Git fsck to find dangling commit objects. To find a specific stash, search its diff with grep. Always use Git Stash Apply instead of pop when conflicts are possible. Let's run through some common interview questions. Why does cherry-pick create a new SHA? SHA includes parent, which changes. How to recover a stash lost after pop conflict? Use reflog or Git fsck. When should you not use cherry-pick? For regular backports, redesign branch strategy. And a few frequently asked questions. Can you apply a stash on a different branch? Yes, stash is not branch-specific. Can you cherry-pick multiple commits at once? Yes, list SHAs or use range. What's the difference between pop and apply? Pop removes stash, apply keeps it. To recap, stash is for temporary parking, cherry pick for precise backports. Always annotate cherry-picked commits to avoid duplicate conflicts. Use apply instead of pop to keep a safety copy. Ready to go deeper? Up next, Git Workflows, then GitHub pull requests and code review, then Git tags and releases. Find them all at TheCodeForge.io. Thanks for watching. The full article and code examples are covered in detail at TheCodeForge.io.